Just do the first question at the page number 11, the first warm-up question. Right, before we go into the A-level questions, right? Just do that. I'll give you just 2-3 minutes. Alright, මම කරන්න පළවෙනි එකනේ. මම පොඩ්ඩක් පළවෙනි එක කරන්න මේ මම කියන්නේ ඔයගොල්ලෝ තාම simultaneous equation ගැන පොඩි idea ගන්න නැහැ නේ. Right, I'll do the first one, right? Okay, this is regarding warm up, right? Alright, මේකක් පොඩි learning වැඩක් තමයි, හරි? So, this page number 11, the warm up questions, right? Right, so basically there are almost 5 steps. There are almost 5 steps, right, to completely solve a chemical calculation question, right? Chemical calculation question එක complete solve කරන්න සාමාන්‍යයෙන් steps 5ක් follow කරනවා. හරි? අපි පොඩ්ඩක් ඒ ගැන කතා කරමු. ඒකත් එක්ක තමයි මේ කතාව වෙන්නේ, right? මෙන්න මේ steps ටික කරන්න ඕනේ, right? Steps to follow, right? මුලින් මේක ඔහෙ පැත්තක වා ලියා ගන්න, right? Steps to follow. When solving a chemical calculation problem. The first thing, right? The first thing is identifying the goal. Identify the goal and assign x moles, y moles to the chemical species responsible for the goal. Right? Then මේ question එක බලුවොත් පොඩ්ඩක් මේ question එකත් එක්කම ඔයාලා මම කියලා දෙන්නම්. They are saying a solution contains sodium oxalate and magnesium chloride, right? So some procedure is given, right? So your goal is to basically to find out about the two chemical species, sodium oxalate and the magnesium chloride, right? So මේකෙදි අපි මේ sodium oxalate, that amount can be assigned as x moles and the magnesium chloride amount can be assigned as y moles, right? Problem එකේ involved වෙන, right? Involved වෙන chemicals ලට x moles y moles කියලා දාගන්න. The two salts here are the sodium oxalate and the magnesium chloride. So assign sodium oxalate amount as x moles, magnesium chloride amount as y moles. That is the idea, right? Okay. After that, right, the second thing, right, write in the balance, right, chemical or ionic reactions involving in the processes. Procedures, right? ඊළඟට කරන්න ඕනේ. ඒ කියන්නේ දැන් මේකේ ගත්තොත් හරි with the procedure 1 you have the sodium oxalate and the magnesium chloride that solution and you are adding NaOH to that thing. So you are supposed to write the chemical reactions there. Right, at the flask you have the sodium oxalate and the magnesium chloride, no? So you are adding NaOH and some precipitate is obtained, so that you are supposed to come up with the precipitation reactions there. That is this. හරි? තුන්වෙනි කාරණය. Right? The third one. Right? Coming up with the simultaneous equations. Right? Simultaneous. So you know, as you are with two unknowns, x moles and y moles, you need to come up with two simultaneous equations to completely solve for those two unknowns, right? So the third step is coming up with the simultaneous equations, right? Right? Write in the simultaneous equation. equations using the data points. For that, we get the help of data points. I'll explain you what data points are. Right? Normally, data points are some numerical values, right, where you know exactly the chemical species responsible for that value, right. Data points are some numerical values where you know exactly 100% about the chemical species responsible for that value, about the chemical formula of the species responsible for that value should be known for a numerical value to consider as a data point. In this case, you see, in this case, right, the dry mass of the precipitate observed was 0.85 grams. 0.85 grams. Normally, the best data points in your problems appearing are the precipitation masses and the titration readings. Those are the major two stuff coming up as data points. Precipitation masses. So actually you know, completely know about the precipitate, no? After writing the balanced chemical reactions for the precipitation reactions, you exactly know about the precipitates available there. So the precipitation mass is going to be a data point, right? Another data point is actually the titration reading. So the titration, the concentration and the volume, those readings of the titration are normally going to be a data point. Right? With the use of data points, you are supposed to come up with the simultaneous equations. So if you are with two unknowns, definitely you need to come up with two simultaneous equations. If you are with three unknowns, basically you need to come up with three simultaneous equations like that, right? Okay. So we will follow these steps, right? So if you are to follow these steps, definitely you can easily solve the question complete, right? The fourth one, solving for x and y. Solve the simultaneous equation for coming up with the x and y. Solve for x moles and y moles by solving simultaneous equation, right? And finally, Lama, if you know the x moles and y moles, you can definitely come up with the concentrations. What are the concentrations? Concentration means the amount of moles divided by the volume. If you know the x, you can come up with you can divide that thing with the volume of the solution and come up with the concentration, right? So if you know the number of moles, definitely you can come up with the concentrations, what they may ask, right? Or you can come up with the mass percentages as well. If you know the number of moles of the corresponding substance, that can be multiplied by the g mole minus 1 data, mole weight, to come up with the mass. That mass will ultimately lead you to the mass percentages, right? If you had solved for the x and y, the thing is done naturally, right? So the fifth step, right? Completing the question. The answer by finding basically concentration or mass percentages. Or sometimes it is about the percentage yield. In 2024 paper, a new concept arises with the percentage yield as percentage yield, right? Those are the 5 steps to follow. So with this warm up thing, we are expected to come up with these 3 major points. මේ warm up questions දෙකත් එක්ක අපි මෙන්න මේ තුන වලට හොඳට පුරුදු කරන්නයි යන්නේ. Simultaneous equation ගත්ත කියනවා ඊට පස්සේ question එක ඉවරයි. Simultaneous equation දෙක ගත්ත කියන පස්සේ ළමයි මේ simultaneous equation solve කරන්න උඩ පුළුවන් නේ. පොඩි කාලේ වැඩනේ. grade 11 stuff no solving simultaneous equations. ඊට පස්සේ xy හොයාගත්ත කියලා කියන්නේ moles ගාන volume එකකින් බෙදුවන concentration එක එනවා. moles ගානේ mass එක ගන්න පුළුවන් ඔයාට mole weight එකකින් වැඩි කළා ඊට පස්සේ ඒක total mass එකකින් බෙදුවම percentage එක එනවා. mass percentage එක. This stuff are very easy. This is the hard stuff. මේ ටික තමයි වැඩි. මේ කියන්නේ මෙන්න මේක තමයි මෙන්න මේ දෙක තමයි case එක. x moles by moles දාන්න පුළුවන්. මෙන්න මේ දෙක තමයි වැඩි. දැන් මේක තමයි මුලින් කතා කරලා හිටියේ. හරි? මෙතන කතා කරලා හිටියේ. දැන් කතා කරන්නේ මේක. right? අර මේ දෙක හොඳට පුළුවන් කරගත්ත කියන්නේ question solve කරන්න පුළුවන්. මේ steps පහේ එකතුවක් තමයි ඔයාගේ chemical calculation question එක කියලා කියන්නේ. reduced calculation question එක කියලා කියන්නේ මේ right steps පහේ එකතුවක්. මේ ටික පිළිවෙලට කරන් ගියනම් ලස්සනට question එකේ answer කියනවා. අපි බලමු කොහොමද question එක approach කරන්නේ. මුලින්ම මේක පොඩ writing simultaneously කියන තැනට වෙනකම් මේ question එක solve කරමු. මේ two warm up things are there. So I'll do the first one, right? බලන්න පළවෙනි warm up එක කරන්න. ඔයාලට second එකට ඕනම් try කර chance එකක් දීලා. හරි මෙන්න මෙහෙම වැඩි යන්නේ. this done යා මේක උඩ හොඳට කොටු කරලා ලියා ගන්න. කරෝ ලියලා නැත්නම් ලියා ගන්න මේක. මේ steps ටික තමයි කරන්නේ හරි. මේ ටික හරි පිළිවෙලට කරන්න වැඩි ඉවරයි. ඉතින් දෙයක් නෑ ඔගේ. Hurry. Right. We'll do the first one. One more question one. Hurry. Hurry. Okay. अब බලමු පළවෙනි එක. හරි මේ question එක කරලා එන්න බලන්න මම පොඩ්ඩක් වෙලාව දෙන්නම් ඔයගොල්ලන්ට මේක ලියාගෙන ඉඳිම මේක ලියාගෙන වෙලාව දෙන්න. right අපි පොඩ්ඩක් question එකට එමු. see this S solution contains sodium oxalate and magnesium chloride. So the first thing is assign X moles Y moles for the interested chemical species. Right? හරි එහෙනම් find out the goal and assign X moles Y moles. So let this is the first step. Let sodium oxalate මේක ලියන්න is equal to X moles and magnesium chloride is equal to Y moles. හරි මොකක් කර දිනන නම් in මොකක් හරි in 10 grams of the sample නැත්නම් in 25 milliliters of the solution. ඒක ලියන්න. හරි මෙතන මේකේ question එකේ නැහැ ඒක. හරි මේ question එක අපි මේ steps තුන විතරයි follow කරන්නේ. අපි question එක complete question එක නෙමෙයි දීලා තියෙන්නේ. හරි අන්තිම question එකක් වුණොත් ඒගොල්ලෝ දෙයි completely. හරි in මොකක් කරලා ලියන්න in grams නම් in හරි මොකක් කර ප්‍රශ්න එක අහන්නේ in මොකක් හරි grams of නැත්නම් මේ centimeter cubes of solution. හරි ඒක ඇල ලියන්න question එකේ හැටියට හොඳයි. හරි first point. The second point coming up with the constructing the balanced chemical reactions, right? හරි වැඩි කරමු. හරි මුලින්ම පොඩි පින්තූරයක් අඳින්න නැත්නම් වැඩි ටිකක් අමාරුයි. procedure 1. Procedure 1, right? Procedure 1. Got the end. To a 20 cubic centimeters of 20 in make real question again in 20 cubic centimeter solution. Hare? Hare? 20 cubic centimeter consider කරලාදී? හරි. ඒක ලියන්න. ඒක වැදගත්. හොඳ questions වල theory මේක ගත්ත කියලා. X moles in 20 cubic centimeters වල. So අපේ question එකේ 20 එක 10 කරලා ගන්නවා. for XO2 වෙනවා moles ගන්නවා. ඒ indicate කරද්දී අනිවාර්යෙන් ලියන්න කොච්චරකද මේ x moles y moles තියෙන්නේ කියලා. right? හරි. ඊට පස්සේ procedure 1. see පොඩි බිඳුවක් හදගමු. පොඩි එකක් හදගමු. So you have 20 cubic centimeters of the solution. This kind of a concentration stuff, right? So excess of NaOH was added to now you have the sodium oxalate and magnesium chloride. හරි. ළමයි මේ flask අඳිද්දි හැමතිස්සෙම you are supposed to come up with the number of moles there. Right? Always write the chemicals with the amount of moles there. You have X moles here, Y moles here. Right? What they are doing is actually adding some excess of NaOH. Adding some excess of NaOH. Na plus and OH minus. Hurry. Okay? Let's write the reactions involved in this procedure. Right? Let's write the reactions involved in this procedure, right? Write in the balanced chemical or ionic reactions involving with the procedure, right? Okay. So they are saying some precipitation occurred. They are saying some precipitation occurred. Precipitate occurred. Mass is given, right? As 0.585. හරි. දැන් මෙන්න මේ procedure එක දාලා equation එක ලියමු. හරි when handling always handle one by one procedure one by one. පළවෙනි procedure එක ඉවර කරලා තමයි second procedure එහෙම යන්නේ. හරි? right. හරි බලන්න. දැන් කොහොමද තියෙන්නේ? ඔන්න reaction එක ලියන්න යන්නේ. අදාළ ටික කට්ටිය අයින් කරන්න. දැන් ඕගොල්ලෝ knowledge දීලා තියෙන්නේ. Sodium plus never involved in precipitation. Precipitation යන්නේ මේක. Precipitation එක. හරි sodium plus never involved in precipitation. හරිද? ඊට පස්සේ ඒක තමයි මෙයා involved වෙන්නේ නැහැ. හරි? right? මෙයාගේ cation එක involve වෙන්නේ නැහැ කියලා කියන්නේ මේගොල්ලෝ enhance කරන consider කරන් දෙයක් නැහැ නේ. Are you with me? If the cation of this stuff won't involve in the precipitation thing, no need to concern the enhance of this one. දැන් මෙයා cation එක වැඩිට precipitation එකේ participate කරන්න බැර නම් cation එකට මුන්ගේ anion ගේ වැඩක් නැහැ නේ consider කළොත්. The cation anion, that is the exchange no, for the precipitation. So what is the possibility there? Just one single possibility. The magnesium guy precipitate with the OH minus. We know magnesium hydroxide is a precipitate, right? So let's try the reaction. That is your reaction, right? So magnesium hydroxide is your precipitate, right? So when writing precipitation reactions, right? So now you know magnesium hydroxide is the one here. Write the reaction first of all, right? So NaOH reaction with magnesium chloride, right? Magnesium chloride reacting with NaOH. Just complete the stuff. Ion exchange, right? Will give you magnesium hydroxide. Ion exchange, right? And this thing, sodium chloride. Always mark the precipitate, right? 2 of OH minus ions are appearing. That means 2 of OH minus are needed, and two Na pluses and 2 Cl minuses are there. So 2 of this thing is needed here, right? Okay. This precipitation mass is given. Hurry. Right. Then මෙහෙම තමයි කතාව. දැන් මෙන්න මේ ස්ටෙප් දෙක සාමාන්‍යයෙන් එකට තමයි හැන්ඩල් කරන්නේ. මේ ස්ටෙප් දෙක එකට හැන්ඩල් කරන්නේ. Write in the balanced chemical reactions and the write in the simultaneous reaction දෙක එකට හැන්ඩල් කරන්න. හොඳේ. එක ප්‍රොසීඩිය එකකට මේ දෙක එකට හැන්ඩල් කරන්න. ඊට පස්සේ ප්‍රොසීඩිය එකට ඊට පස්සේ යන්න. හරි? මේ බාන්දා වැඩේ කරන්න හැටි. මෙන්න මේක කතාව. දැන් කොහොමද මේකේ simultaneous reaction එක ගන්නෙ? මේක හොඳට බලන්න ලවා. This is very important. මේ තමයි ලේසිම විදියට question එක solve කරන්න තියෙන්නේ. හරි? වෙන විදිහේ මේ ලේසිම විදිය. ඔයාලට හැමදාම මේ steps එකකින් question එක solve කරන්න පුළුවන් මේ විදිහට ගියොත්. හරි? right. මෙහෙම වැඩේ යන්නේ. දැන් මේකන ඔය data point එක. This is your data point no. This is your data point. It's a precipitation data. So we are supposed to write an equation for this precipitate. The first simultaneous equation is written for this precipitate. See? Write in the simultaneous equation choosing the data points. For our data points only we are writing the simultaneous equations, right? So this is our data point, right? So we are supposed to write the first simultaneous equation for this data point, right? So the main data point is simultaneous equation එක ලියන්න ඕනේ. ඊට පස්සේ ඉතින් ප්‍රශ්නේ මොකද්ද? මෙතන x එකක් නැහැ. xy is not available. The simultaneous equation should be built up with the in terms of x and y. So we have to bring these x and y's towards here, towards this chemical. මේ chemical එක ගාවට x y ගේන්න ඕනේ. නැත්නම් simultaneous equation එක ලියන්න බෑනේ. හරි simple logic එකක් තියෙන්නේ. හරිද? From here you are supposed to come up with the simultaneous equation. Simultaneous equation should contain the unknowns, but unknowns, that means x and y's, right? So you don't have x and y's with this one yet, right? So you need to, right, come up with this guy's number in terms of x and y. Hari, balan, කොහොමද ගන්නෙ? So the number of moles of this thing is y moles. That is where we need the relationship of the chemical equation, right? That is where we need the help of the chemical equation there, right? To convert the x and y's to the data point. To convert the x and y's to the data point. So you have the y moles here. This is also y moles. හරිද? ඔය data point එකට ඔයාගේ unknowns convert කරගන්න තමයි ඔයාට chemical equation එක ඕනේ වෙන්නේ. හරියට logic එක අල්ල ගන්න වැඩි. හරි? Right. Now write the equation. Now write the first simultaneous equation. For what? For the mass of precipitate. For the data point. For mass of, right? What? Magnesium hydroxide precipitate. Data point එකේ අනිවාර්යයෙන්ම exactly chemical එක දන්න කෙනෙක්. In terms of grams, I am writing the simultaneous equation, right? Okay. Hare. That is 0.585, right? So we need to come up with the mass of this one. මෙයාගේ mass එක තමයි මෙයාට සමාන වෙන්නේ. Right? Okay? So how to come up with the mass of this one? In terms of y. In terms of y. So this guy's g mole minus 1 value, they will give you marks for those. So just write them. G mole minus 1 value for magnesium hydroxide. What is that value? Magnesium is 24. You have 17 here. 2 of those. 34 and 24, that is 58, no? Right now? 34, yeah. 58 G mole minus 1. So 58Y is the mass of magnesium hydroxide in terms of Y. 58Y. Right now? 58 g mole minus 1 into by, right, moles. The moles things will cancel off to give you the number in grams. 58y is equal to what? 0.585. That is your first simultaneous equation. So what we need is such two simultaneous equations, right? Always we are writing the simultaneous equation for the data points. The numerical values we exactly know about the chemical, right? Chemical or chemicals, right? Okay, first data point is done. Second done. Let's copy the second procedure. Right, I'll write the second procedure now. පහළ නේද? හරි හරිම ලොජිකල් විදිහට යන්නේ හොඳේ. ඔය data point එකට අවශ්‍ය කරන xy ගේන්න තමයි ඔයාට chemical equation එක helpful වෙන්නේ. Chemical equation stoichiometry එක helpful වෙන්නේ. හරි? බලන්න මේ තියෙන සම්බන්ධතාවය. Procedure 2. Right? So to another 20 of ST solution. So you have another solution. 20 cubic centimeters means there you have the sodium oxalate as well as the magnesium chloride. Right? So the numbers x moles, y moles, x moles of this thing and y moles of this thing in 20 cubic centimeters. Right? Okay. Now to that you are adding some dil H2SO4 and the KMNO4, that is titration. Dil H2SO4 is added, right? Dil H2SO4 is without any redox property, right? And some titration. KMNO4, right? So what they are saying? The consumed amount is given 0.1 molar, 15 cubic centimeters. This is your second data point. CV data. All these titration readings are good data points, right? So this is your second data point with the KMNO4. So we are supposed to write your second simultaneous equation for the number of moles of KMNO4. Right? The CV data is given, that means you can copy the moles there, right? Okay. So first of all, try to bring up the chemical equations there. So sodium plus no use, magnesium 2 plus no use, S block guys, right? So what happens here? What happens here? MnO4 minus always tends to go towards Mn2 plus, right? It's a reduction, so we are expecting some oxidations here. So oxalate can get oxidized as well as the Cl minus. Both will get oxidized, right? So two reactions are possible there. One reaction is actually MnO4 minus reacting with the oxalate to convert it to the Mn2 plus, and this will give you the CO2. And the other reaction is MnO4 minus reacting with Cl minus to give you the products, right? The two reactions. That's right. මේ පිළිවෙලට යන්නේ. මේක දැම්ම chemical reactions ලිව්වා. ඊට පස්සේ තනට යන්නේ. හරි? Now just writing chemical reactions. Right. So that's right. So the two chemical reactions, right? So MnO4 minus reacting with oxalate C2O4 minus, giving you the Mn2 plus CO2. This is one thing in acidic medium. The other reaction is MnO4 minus reacting with Cl minus to give you the Mn2 plus and the Cl2. Right, just do this up, right? So you have two of the carbons here, just balancing, simple balancing. මම ටක් ගාලා කරලා දානවා. what balance කරන්න පුළුවන්ද? So just kind of a 5 electron difference, plus 7 to plus 2, no? 5 electron difference. Here just kind of a plus 6, 10, 4 electron difference, right? 4 electron, this is plus 6, no? That's 10, plus 6 plus 8, no? 2 electron difference, plus 8, right? So you need to multiply this thing with 5. This becomes 10 then, this thing with 2, like that. Is balancing. So minus 2, minus 12, and here plus 4, 16 of difference, so 16 H pluses and 8 H2Os. Quickly complete the other one as well. Completing the two chemical reactions. So first of all, you need 2 here, as 2 chlorines are there. So you have 5 units of difference, you have 2 units of difference. So 2 here, 5 here, right? So minus 2 minus 12 is there. So here plus 4 again 16, sir. Right? Some 8H2O. Right, we are done with the chemical equations. Alright? After the chemical equations, so we have to come up with the simultaneous equations. Right? So that we have to bring the xy's towards the data point, towards the chemical response of the data point. That is MnO4 minus, right? This data point is with the MnO4 minus. So you have to bring the x and y's towards the data point MnO4 minus. X ko y ko the x is here, x is here, y is here. Right? This is 2y, this is 2y, right? So y moles of magnesium chloride means 2y moles of Cl minus, right? 2y moles of Cl minus, right? Okay. Alright, then bring then මේගොල්ලෝ ගේන්න ඕනේ data point එක මොකක්ද මෙතනට ගේන්න ඕනේ. Data point is regarding KMnO4. Right නේ? හරි. එහෙනම් මේක x moles මේක කීයද? අපි ඉගෙන ගත්තේ x moles representing 5 portions. We need such 2 portions. So this value is x moles for 5 portions divided by 5, such 2 is needed. This value y moles, sorry, 2y moles is for 10 portions. 10 portions, we need such 2 portions. 2y is for 10 portions, we need such 2 portions. Alright, so that is going to be 4 over 10, that is going to be 3 over 5. 3 over 5. Sorry, 2 over 5, no? 2 over 5. Right, no? Shape ne? 2 over 5. Alright, then second simultaneous equation here. To this data point. What is this data point? This is all about moles of KMnO4. CV data means all about moles of KMnO4. So write the second simultaneous equation there for moles of KMnO4. In terms of moles, I am writing the equation, right? ඔය simultaneous equations අතල ළමයි එක එක gram mole කියලා ලියන්නේ නැහැ හොඳේ. simultaneous equation එක ලියගෙන කෙලින්ම numerical values තියෙන එකක් හරි. gram mole ඒව ලියන්නේ නැහැ. ඒක ඕන මෙතන දාගන්න. equation දෙපැත්තෙන් තියෙන grams කැපිලා යනවා. මේක දෙපැත්තෙන් moles තියෙන්නේ. හරි. ඉතින් මුලින්ම moles ගන්න හොයාගමු. KMnO4 moles ගන්න. MnO4 minus moles ගන්න. right here. මුලින්ම MnO4 minus moles ගන්න හොයාගමු. with the CV. That is 0.1 into 0.1 mole into 15 into 10 minus 3. හරිනේ? 0.1 mole dm minus 3 into 15 into 10 minus 3 dm3. හරිනේ? mole minus 3 mole dm minus 3 into 15 into 10 minus 3. 10 minus 3 කරන්න ඕනේ. මොකද decimeters වලින් ලියන්න ඕනේ නැත්නම් moles වෙන්නේ නැහැ. Right? So this value is given as what? 1.5 into 10 minus 3. So this value is equal to the summation here, right? 2x over 5 plus 2y over 5 is equal to this value. So you can simplify the stuff, right? So it is going to be 2x, the second simultaneous equation is going to be 2x plus 2y is equal to 7.5 into 10 to the power minus 3. That is your second simultaneous equation. හරිද? ඔන්න ඔය equation දෙක solve කරගත්තා නම් ඔයාලට xy හොයාගෙන concentration හරි මොනවා හරි හොයන දෙයක් හොයාගන්න පුළුවන්. හරිද? ඔය steps දෙක solve කරගත්තා නම් x moles y moles හොයාගන්න පුළුවන්. ඊට පස්සේ volume එකෙන් බෙදුවා නම් concentration එක හොයාගන්න පුළුවන්. එතන නම් question එක අහලා නැහැ. question එක අහලා තියෙන්නේ just to come up with the two simultaneous equations. අපි gradually මේක build up කර යන්න ඕනේ. හරිද? So just complete the stuff. ඊට පස්සේ ළමයි දෙවෙනි එක try කරන්න. I'll give you some 5 minutes. Try the second procedure. Second question there, right? හරලම අපි බලමුද right ඊළඟ කතාව second form of question එක let's do the second one. බලන්න ඔයාලා simultaneous equation එක build up කරන්න පුළුවන් වුණාද කියලා. Right, question number 2. Right, see. Solid sample A contains copper sulfide and FeS. Right, so the two chemicals in this question is CuS and FeS. Identifying the goal. Identifying the goal. So let CuS is equal to X moles and FeS is equal to Y moles, and yeah, they are referring to 5 grams of the sample, no? In 5 grams of sample. Some impurities also there, right? Some impurities also there in this case, right? Then they are saying 5 grams of sample A was taken and titrated with 0.1 molar dichromate. So now that is the procedure 1, right? The first para, right? You are supposed to read, right? You are supposed to read until the data point is observed. හරි සාමාන්‍ය ළමයි question එක කියවද්දි දිගට ඔක්කොම ඉඳන් මුල පටන් ගත්ත ඉඳන් අන්තිම වෙනකන් කියවගෙන යන්නේ නැහැ. හරිද? පළවෙනි data point එක හම්බ වෙනවා කියලා ඒ වැඩේ ඉවර කළා තමයි ඊළඟට යන්නේ. ඔයාලට මතකද දැක්කනේ? අපි මෙතන පළවෙනි data point එක වෙනකන් කියලා precipitation mass එක වෙනකන් කියලා එතනට වෙන වැඩේ complete කරලා ඉවර වෙලා තමයි අපි second data point එකට දාලා දේවල් කියවන්න පටන් ගත්තේ. හැමතිස්සෙම එහෙම කරන්න. ඔහේ නිකන් මුලින් ඉඳන් අගට කියවන් යන්න එපා. පළවෙනි data point එක වෙනකන් මුලින් කියවන්න. කියවලා ඒකට දාලා simultaneous equation එක achieve කරාට පස්සේ විතරක් එතනින් ඉස්සරහට කියවන්න යන්න. හරි? එහෙම කරන්න එතන මාර lazy question එක. හරි? So until the first data point is met, we have to understand the question, right? So 5 grams of the sample A was taken and titrated with 0.1 molar dichromate, and endpoint was observed at 20 cubic centimeters, right? Let's complete that stuff, right? So 5 grams of the sample was taken, 5 grams were taken, and that sample contains CuS, right? Some impurities also there, and CuS and FeS. When drawing this one, right, put those amounts as well in terms of X and Y. X moles, Y mole. So this is my flask එකක් අඳින්නම අනිවාර්යෙන් ඒකේ chemical එකයි එයාට දාලා moles ගන්න in terms of X and Y indicate වෙන්න ඕනේ, right? So titrated with acidified and titrated. Acidified, right, with the H2SO4, and then titration. Okay, titration had been done, right? So dichromate K2Cr2O7, and they had used 0.1 molar dichromate, and at the end point, the end point reading goes like 20 cubic centimeters. So this is your data point. The titration reading is always a data point, right? So this is your data point. A numerical value where you exactly know the chemical responsible for that total value. It's a data point. Then make a data point එකක් නෙමෙයි හොඳේ. හැම numerical value එකක්ම data point එකක් වෙන්නේ නැහැ. මේ value එක data point එකක් වෙන්නේ නැහැ. Why is that? Because you have a inert impurity. You don't know the chemicals in this stuff. ඒ data point එකට අදාළ numerical value එකට අදාළ හැම කෙමිකල් එකක් ගැනම ඔයා දැනගන්න ඕනේ. නැත්නම් ඒ එතනට අදාළ හැම කෙමිකල් එකකම කෙමිකල් ෆෝමියුලා එක ඔයා දැනගන්න ඕනේ. එහෙම වුණොත් විතරයි data point එකක් වෙන්නේ. දැන් මේක data point එක නෙවෙයි මේකට ලියන්න යන්න එපා simultaneous equations. Hari, you don't know about the impurity here. You don't know about the chemical formula of the impurity here. තේරෙනවද? වැඩි තෝරගන්න හැටි. හැබැයි මේ value එකට දාලා chemical component එක සම්පූර්ණයෙන්ම දාන්න ඕන. That is all about the dichromate. Right? So this is a data point. මේ data point එක නෙමෙයි. මෙතන ඉන්න එක්කෙනාගේ chemical formula එක දන්නවනම් මේ data point එකක් වෙනවා. So you can come up with the mass of this thing plus mass of this thing plus mass of this thing will be equal to the 5 then. It become a data point if you only if you know the chemical species, the chemical formula of the species here. But you don't know, so this is not going to be a data point. So make the equations here and Hari? Hari data point right? Hari. Right. Let's come up with the equations here. Right? So this is the data point. So this is the first simultaneous equation. Right? So first of all, so we have to bring these x and y values towards the dichromate. We are supposed to write the simultaneous equation for this thing, for the number of moles of dichromate, so that we have to bring these unknowns to there. So we have to bring those x and y values towards dichromate. For that, we need the stoichiometric relationships of the chemical equation, right? So with the use of chemical equation, with the use of stoichiometry there, we can bring the x and y values towards the dichromate to come up with the data point. Right? That is what we are doing here, right? Hare. And first of all, now we need to come up with the equations possible, right? So what are the equations possible here? So K plus is there, CrO4 2 minus is there. This is just to acidify the medium, the H2SO4, right? So you have the Cu2 plus here, S2 minus, Fe2 plus, and S2 minus, right? So what will happen? So K plus is no use, right? With the redox reaction, no use with the K plus. So dichromates, what will they do, right? So dichromates converts to in acidic medium Cr3 plus, right? So just plus 6 guys convert into plus 3s. That means it's kind of a reduction. So we are expecting only the oxidations at the flask, right? Cu2 plus can't get oxidized because it is the highest oxygen state available for the copper. Copper 2 plus, bad. Copper 2 plus, yeah. But S2 minus, yes, it can. Will go to a sulfur, nearest oxygen state line. Fe2 plus, yes, it can. Goes towards the Fe3 plus. S2 minus, yes, it can, right? So we are supposed to copy two chemical reactions. We are supposed to copy two reactions because two salts, both the salts are involved with a reaction, with some reactions with the dichromate, right? So the first is the copper sulfide, right? The reaction with the dichromate and the copper sulfide. So out of copper sulfide, only the S2 minus will be written. Only where the change occurs will be written when coming up with ionic reactions. So this is the first equation. So this guy will oxidize to sulfur towards the nearest oxygen state. This towards the Cr3 plus. What is the second one? It is all about FeS. Both the ions will get oxidized with the dichromate to produce the Fe2 plus will go towards the Fe3 plus, and sulfur will go towards the S2 minus will go towards sulfur, and this thing will convert to Cr3 plus, the dichromate. Let's balance the stuff, right? So minus 2, right? 0, it's 2 electron difference. So you need to come with 2 here. So plus 12 plus 6 electron difference. So you need to multiply this thing with 3, right? This thing is just on, right? Okay. So just balancing, you can do so. No? So H plus and H2Os, right? So minus 6 is there, minus 8 at this side. At this side, plus 6 is there, right? 14 units of difference. So 14 H pluses are needed, and some 7 H2Os here. What about this chemical reaction? So you have 0 here, as a summation is 0, both the Fe and sulfur involved. No? So here plus 3, 0, the summation is plus 3. So 3 electron difference. So you need 2 here as 2 chromiums are available. So plus 12 for this one, plus 6 for this one, 2 of plus 3 means plus 6. So just 6 electron difference. So you need to multiply this thing with 2. That with what, right? So multiply this thing with 2, like this. All the guys with 2. Right? So complete this stuff by adding H pluses and H2O. So you have minus 2 at this side. So you have plus 6 and plus 12 at this side. So 14 units of difference again. Right? So 7 H2Os. Right? That is the balancing. I'll just erase this one, right? Balancing ටික කරගන්න පුළුවන් නෝ ලස්සනට. Right? So let's come up with the values in terms of x and y for the dichromate where the data point is. So you are with x moles of this one, y moles of this one, right? X moles of this one means this is the data point, dichromate is the data point, carrying the data point, right? So x moles for 3 portions, for one portion it is x moles over 3. Here y moles is for 2 portions, so for one portion it is y over 2. This is x over 3, right? So we had brought these unknowns x and y's towards your data point, the chemical of the data point, right? So now you can come up with the first simultaneous equation, right? That is for the moles of dichromate. In terms of moles, we are writing this one, right? So moles of dichromate can be found with the use of CV data, right? So that is actually 2 into 10 minus 3. That is, this value is actually 0.1 into 20 into 10 minus 3. That is 2 into 10 minus 3, right? That moles is equal to the summation of these two number of moles. So that is x over 3 plus y over 2 giving you 2 into 10 minus 3. Just take the simultaneous equation as a linear equation. So we can multiply all the stuff with 6. So that means that will give you, right, 2x plus 3y is equal to 2 into 2 minus 3, that is 0.012. Right? That is the first simultaneous equation, right? From the first para, only until a data point is observed, we had written, solved the question. I mean, we had read the question, right? After data point එක හම්බ වෙන විතරයි question තාම කියවෙන්නේ. Data ඊට පස්සේ ඔයා simultaneous equation එක achieve කරනවා. ඊට පස්සේ තමයි ඊට කියවන්නේ question, right? Right. Let's come up with the next section. What it says, to another 5 grams of sample A. Next one says, to another 5 grams of sample A. So 5 grams. 5 grams means the same situation. Copper sulfide and FeS are there. So you have the X moles as well as Y moles. Acidified Ki was added and resultant solution was titrated, right? So you had added some excess of acidified Ki, right? Then resultant solution was titrated with sodium thiosulfate. titration had been carried out with sodium thiosulfate. Right? So the numbers are given for sodium thiosulfate: 0.1 molar, 10 cubic centimeters, which is your second data point. Which is your second data point, right? It's your second data point. Hydration readings කියලා කියන්නේම data point එක. Precipitation එක කියලා කියනවා data point එකක්. හරි. ඔතන තමයි ඊළඟ equation ලියන්න වෙන්නේ for the number of moles of sodium thiosulfate. හරි. ළමයි sodium thiosulfate always reacts with what? අයුරුත් එක react කරන්නේ. කරන්න දෙයක් නැහැ නේ. We always know no. If sodium thiosulfate is involved in a titration, definitely it's iodine with titration, and iodine should appear at the flask. Without iodine appearance at the flask, you won't go for iodine with titration with the sodium thiosulfate, right? හරිද? හරි. එහෙනම් දැන් reactions එක ලියා ගමු. ඊට පස්සේ ඔයාගේ xy values මෙතනට අපි bring කරන්න ඕනේ, ගේන්න ඕනේ. Right. Okay, let's try to come up with the equations there. So K plus no use. K plus no use. Right? So I minus always tends to come towards I2, x minus form of x2 form. So you clearly see the minus one oxidation state here. Get oxidized to 0. That means it's oxidation. So we are expecting some reduction here. Right? So we have few ions here. Copper 2 plus appearing, S2 minus appearing, Fe2 plus appearing, S2 minus appearing. But we know S2 minus is with its lowest oxidation state. S2 minus is with the lowest oxidation state of sulfur. So can't get reduced further. S2 minus can't get reduced further. It is with its lowest oxidation state. Even the Fe2 plus is with its lowest oxidation state available in aqueous solutions. So only reaction possible here is the reaction between the copper 2 plus and the I minus. Let's write the reaction there. Right? So copper 2 plus reacting with I minus. We know the reaction there. This is a specific reaction, right? So we know it is coming up with 4 of I minus, right? To produce the CuI and the I2. So we can balance this stuff, right? 2 is needed here, 2 here. So with that we can relate, right, some of the stuff, right? So basically you are with x moles of this thing, with this the iodine moles coming as XO2. So we have to bring the x moles, y moles, those unknowns towards the data point, right? To the data point we have to bring the x moles, y moles, right? So now with this equation we can come up with XO2, right? Okay. Now that will be titration. So I2 reacting in sodium thiosulfate, right? Na2H2O3, coming up with two of these things, coming up with I2 to produce the 2 of NaI plus Na2S4O6. So, right, you are with XO2 moles of I2 which has been produced by the reaction of I minus with the Cu2 plus. So that will give you X moles of sodium thiosulfate, 1 to 2 ratio. So we had brought your unknown towards your data point, sodium thiosulfate, right? Now let's come up with the second simultaneous equation, that is for the number of moles of sodium thiosulfate, right? Right, no? Okay. So let's come up with the numbers. Right. This is just 0.1 mole into 10 cubic centimeters, right? This is just 1 into the power minus 3 moles. That means basically it is 0.001, no? So that is equal to x moles. So x moles is equal to Yeah, we'll write it like this. That is equal to this x, right? Number of moles of solid is equal to x. So actually, this is your second simultaneous equation. So actually, your copper sulfide amount is 1 into minus 3 x moles. Right? ඉතින් වැඩි සෝල් කරන්න ලේසියි නේද මේ x දාන්න නම් y දාගන්න පුළුවන්. එතන සබ්ස්ටිටියුට් කරා y හොයාගත්තා. හරි. ඉතින් ඒක හොයන්න කියලා නෑ. අපි මේ warm up වලදී කරලා තියෙන්නේ equation දෙක ගන්න කියලා විතරයි. So you can find the y as well, right? Equation එකත් එක්ක solve කරන්න පුළුවන්. They are just asking us to building up the simultaneous equations relevant to those procedures, right? හරිද? ඒක තමයි ඔයාලගේ warm up questions දෙක. Right. Just complete level. Complete karega. ඊළඟ page එකේ ඔයගොල්ලෝ තියෙනවා මේ titrations දෙකක් ඉදිරි නිකන් බලා ගන්න. Right, simple stuff දෙච්චර කියව ගන්න වැඩි තීරනවා. ඊට පස්සේ යන් තියෙන්නේ past equations වලට, right? Let's try to solve one or two past equations, right? The rest can be done at the online class. අද දෙකක් විතර හදන්න බලමු පාස් වේග දෙකක් විතර. ඊට පස්සේ හිට රයිට පුළුවන්. ඊතුරු ක්වෙස්චන් එක ක්වෙස්චන්ස් එක බලන්න. හරි. මුලින් පොඩ්ඩක් ලීසියක් කරමු. හරි. Let's do the third one first of all. තුන්වෙනි එක හදමුද? ඒක දිගයි ඒක. කමන්නේ අද. That was the question, 2019 question. Right? Just try to do the 2019 question. Question number 3 at the page number 15, 2019 question. Banu try gadil. I'll give you 10 minutes, right? The hack kodina try gadil. Just try to solve this. Question number 3, right? Try to solve the right. Past paper questions. Question number 3. Let's try to solve that. It is happening at page number 15. Barno. questions දෙක තුනක් වැඩිපුර කතා කරා නම් වටිනවනේ. Right. Right, so let's discuss the question number 3. It's past view question, right? Let's use these theories what we have learned for this past view question. This is 2019 question, right? Okay. Question number 3, right? Actually, 2019 question. See what they are saying. The water sample Y contains the anions SO3 minus, SO4 minus, and NO3 minus. The following procedures were carried out for the quantitative analysis of the anions present in the water sample, right? So, we can take our goal as finding out the sulfide, sulfate and the nitrate ions, right? So, the X moles, Y moles, Z moles can be assigned for those guys, right? So, the first point, right? Let, right, so SO3 minus is equal to X moles, SO4 minus equals to Y moles, and nitrate amount equal to Z moles. Right, in 25 cubic centimeters, මේක procedure 1 and 2 වල use වෙලා තියෙන්නේ 25 cubic centimeters. procedure 1 එකේ use වෙන එක දාන්න සාමාන්‍යයෙන්. හරි? සාමාන්‍යයෙන් එතන දාන්න procedure 1 එකේ use වෙන එක. එතකොට procedure 2 එකට වෙන volume එකකට ගියොත් අපිට ඒක corrections කරලා ගන්න පුළුවන්. Right? So මෙතන procedure 1 එකේ use වෙන volume එක හරි mass එක හරි use කරන්න, right? හරි. Okay. So next we are supposed to come up with the chemical equations and the simultaneous equations using the data points, right? So first the procedure 1. See what they are saying. 25 cubic centimeters of sample Y and excess of dilute solution of BaCl2 was added with stirring. So sample Y contains these guys, no? SO3 minus, SO4 minus, and nitrates. 25 cubic centimeters. Right? So you have X moles, Y moles, and Z moles here. Right? Okay. Excess of dill HCl. So excess of dill barium chloride was added, no? Ba2 plus and Cl minus. Right. Thereafter, excess dill HCl was added with stirring to the precipitate formed until these was no further evolution of gas with pungent odor. හරි. දැන් මෙතනින් පස්සේ excess of BaCl2 add කරලා පස්සේ හරිද? ඊට පස්සේ තව මොකක් හරි add කරනවා. මොකද්ද? excess of dill HCl. හරිද? ඒ කියනවායි මෙතන හරිද? ඇසිඩ් එකක් ඇඩ් කරලා තියෙනවා. එතකොට right, we have to think of that. Right, some precipitates are not forming when the medium is acidic, right? So we are looking for some precipitates with the Ba2 plus and the Cl minus by adding those ions, right? But remember that some precipitates are not forming in an acidic medium, right? So see what they are saying. The solution was allowed to stand for 10 minutes. the precipitate was washed and distilled. Yeah, okay. Precipitate is obtained, that means, no? They have obtained precipitate, right? So what would be precipitate now? Precipitate was obtained and dry mass was weight. Got the dry mass. This is as 0.174 grams. Right, no? Alright. So what are possibilities? Let's think of this one. Who is there? Who is there? Right. So this is your data point. Precipitate mass is always a data point. So we have to bring your x and x, y, z values towards the data point. First of all, we need to find out who is this guy here. One or two chemicals would be there, right? So what will happen? So basically, right, nitrates never involved in precipitation. Nitrate ions never involved in precipitation, right? Precipitate time edara? Harada? Ida passe? What about, so no cation appearing here, that means no use of Cl minuses. Cations la nahi, Cl minus ke hitla veranne, right? Yes, any question? Right? So we have to think of barium 2 plus reacting with this one as well as this one. But we know in an acidic medium, sulfides won't precipitate. In an acidic medium, sulfides won't precipitate, as it's not a strong acid anion, right? So sulfides SO3 2 minus won't get precipitated as medium is acidic. Acidic medium and strong acid anions are precipitate. Sulfide. So then only precipitation available is the barium sulfate, right? So you have the barium sulfate here, right? So what is the reaction there? So barium chloride reacting with sulfate ions. Are the make a cow cation and what will happen? This cation of this thing combines the anion of the other stuff, right? So barium sulfate, this is precipitate, and you have 2 of Cl minus ions here. 2 of Cl minus ions here. So you have to write it as 2 of Cl minus, right? Make a Cl2 gillion. You have 2 ions here, 2 kind of ions. 3 ions, actually 2 kinds of ions, Ba2 plus and the Cl minus. So the methane Cl minus because every reaction should be charge conserved as well as mass conserved, right? For the charge conservation, it should become as, it should be appear as Cl minus, right? Minus 2 charging. So let's bring your unknowns towards the data point. So this is our data point, barium sulfate thing. So these x moles, y moles, so that this should be y moles as 1:1 ratio is there. So first equation can be obtained now for this data point. So that is all about mass of precipitate. For mass of barium sulfate precipitate in grams, right? So for the barium sulfate, the molecular weight is needed to come up with mass. So to convert the moles to mass, the G mole minus 1 data molecular weight is needed. So let's come up with that thing. Molecular weight of barium sulfate is actually 233. This is 137, 32 and 4 of 16s, right? 233. So its mass in terms of Y is G mole minus 1 value should be multiplied with moles to come up with grams, right? So that is going to be 233 by, that will be equal to this data point 174. No? Right. So with this is the first simultaneous equation. Anyway, with this you can obtain the y at 0.174. Yeah, I got that value. So Zero 0.174 divided by 230. It's like 7.5 into the power minus 4, right? Like, yeah, 7.5 into the power minus 34. Yeah. The first procedure is done, the data point is the simultaneous execution is also done for the first procedure. Right, let's come up with the second procedure now. See what they are saying. To another 25 cubic centimeters of sample y. So, another 25 cubic centimeters are there. Sample y. Right, so sample y contains these guys, SO32 minus, SO42 minus, as well as nitrate ions. The ones are also known. To that, you added excess of dilyl H2SO4 and acidified KiO3. Excess of H2SO4 is actual to acidify the medium, and KiO3 is supposed to do some redox reaction, IO3 minus, right? And the liberated I2 was titrated with sodium thiosulfate, no? And the amounts consumed are given as 0.02 molar. That is your data point, right? 20 cubic centimeters. That is your second data point. Number of moles of sodium thiosulfate. So you have to bring these X, Y, Z towards the sodium thiosulfate, right? So first of all, for that, let's come up with the chemical equations, right? To relate these X and X, Y, Z's to the thiosulfate, right? So K plus, no use. This is just to specify the medium. So IO3 minus, what happens with that? So IO3 minus X minus form or the X2 form, right? IO3 minus is it plus 5 oxygen state of iodine. So when reducing towards 0 or minus 1, the closest oxygen state is 0, right? So IO3 minus prefers I2 as a product. So they are saying as well, no? Right? So reduction. So we are looking for some oxidation here at the flask, right? If you are with any chemical with its highest oxygen state available, such things can't get oxidized, right? So nitrate with plus 5 oxygen state of nitrogen can't get oxidized. Sulfate with plus 6 oxygen state of sulfur, that is the highest oxygen state of sulfur, group 16 element, that can't get oxidized. So only available reaction is the reaction between the IO3 minus and the sulfite ions in acidic medium, right? So let's come up with the equations there. So IO3 minus reacting with sulfite to produce the I2, and the sulfate will oxidize to sulfate, no? Just balance the stuff. So you have 2 iodines, so 2 is needed here. So plus 10 as a summation of oxygen state for 2 iodines, 0 here, 10 electron difference, plus 4 and plus 6, 2 electron difference. So you should multiply this thing with 1 while this thing with 5. Right now, so balancing the stuff, right? So H plus the medium balancing, right? H plus and H2 things, right? Charge balancing, minus 2 is there, minus 12 is at this side, and at this side minus 10 is there. So 2 H pluses are needed and 1 H2 molecule here. Right, so after this, the titration thing is happening with thiazolate and I2 identity titration, right? So 2 of Na2S2O3 reacting with the so produced I2 to come up with the 2 of NaI plus the Na2S4O6, right? So number of moles. So we have to bring these things towards the thiazolate, right? Towards the data point, our goal, right? So here, this one coming up with X moles. So 5 to 1 ratio, right? So this is going to be XO5. X moles is for 5 portions. So 1 portion means XO5. This is XO5. This is the number of moles of I2 produced, the XO5, right? That means twice of that will consume as sodium thiazolate, right? So that is going to be 2XO5. So we brought this unknown towards our data point, chemical of the data point, right? So we can come up with the second equation now, right? That is for the moles of sodium thiazolate. Right, so it's going to be 2XO5. This is the moles in terms of X unknown for thiazolate, and this side it says 0.02 into 20 CV data. 0.02, no? Yeah. In terms of moles, right? That is why I put it here, right? In brackets, right? So let's try to multiply the stuff, right? Because 10, right? Multiply by 5 will give you X, right? Your X as this becoming 0.1, 1 into minus 3, no? X is equal to 1 into e to power minus 3 moles. That is your equation number 2, right? Right. So 2 things have been done. Final stuff. Right. Procedure tree. ඔයාලට පේනද ළමයි මේ මම මේ අර එක ප්‍රොසීඩියක් ඉවර කරනකම් ඊළඟ ප්‍රොසීඩියක් කියවන්නේවත් නෑ අඩුවනේ කියවන්නේවත් නෑ. හරි නිකන් ඕගොල්ලෝ ඔළුවට බර දාගන්න එපා. ඊට පස්සේ ඔක්කොම ජම්බල් වෙනවා. data point එකක් එනකම් කියවලා ඒ data point එකට අදාළ procedure එක complete කරලා ඉන්න. simultaneous execution එක obtain කරලා ඉන්න. ඊට පස්සේ විතරක් ඊළඟ procedure එකට යන්න. හරිද? ওই විදිහට ready කරොත් මාරලා එසින් මේ ගේම ගහන්න පුළුවන්. හරි? නැත්නම් ඔක්කොම නිකන් මුලින් ඉඳන් කියවන්න ගියොත් ඔක්කොම ජම්බල් වෙනවා. ඔක්කොම ඔළුවේ නිකන් විකාරයක් වගේ එනවා. එහෙම කරන්න එපා. Just read until you meet a data point. Right? Then complete the stuff up to there. Try to come up with the simultaneous equation from that data point. After that only you are supposed to read the rest of the question. Right? Okay. Next one. Procedure tree. See, the filter rate from the procedure 1. The filter rate from the procedure 1 is actually this one. Right? The filter rate. Filter rate this procedure, the filter rate contains NO3 minus, right? Filter rate contains NO3 minus. This is the filter rate of the procedure 1. The solution. Filter rate is this thing. Because SO4 2 minus ions have been precipitated like this, and what happened to the SO3 2 minus? Actually, SO3 2 minus is released as SO2. Right? SO3 2 minus, when you are to add some H pluses like this, right? The SO2 will release. That is what they have said, that gas is released. No further evolution of gas with pungent odor. මොකක්ද මේ සීන් එක? ඇයි මෙයා මෙහෙම dissolve වෙන්නේ? මෙයා dissolve වෙන්නේ මෙහෙමයි ළමයි. මෙයා dissolve වෙන්නේ, right? Your barium, how this barium sulfide dissolves in acidic medium. Barium sulfide will react with 2 of HCl to form barium chloride and H2SO3. Barium chloride and H2SO3. The H2SO3 can be written as H2O plus SO2. හරිද? ඔහොම තමයි barium sulfide කියන එක කෙනා acidic medium එකේ dissolve වෙන්නේ. හරිද? ඒ කියන්නේ precipitates acidic medium වල dissolve වෙන්නේ ওই විදිහට. Precipitates acidic medium dissolve වෙන්නේ by ion replacement reactions. acid එකේ තියෙන H+ ඇවිල්ලා අරගෙන anion එකට set වෙනවා. acid එකේ anion එක ඇවිල්ලා precipitate එකේ cation එක set වෙනවා. Like this. So this is barium chloride and H2SO3. Normally H2SO3 is written as H2O plus CO2. H2SO3 and H2SO3. Like H2CO3. H2CO3 is always written as H2 plus CO2, like that, right? Okay. හරි. ඒකට ඔය තමයි නම් ඔයාගේ filtrate එකේ තියෙන්නේ මෙයා විතරයි. This is the filtrate. So the filtrate contains Z moles of nitrate ions. It is not participated in any of the reactions from here, right? So your filtrate of the stuff contains NO3 minus ions. Z moles of that thing. See what they have done. This filtrate from procedure 1. Right. See what they have done. The filtrate from procedure 1 was neutralized with dilute NaOH. They had a NaOH, and to it excess of aluminium powder, and NaOH was added. මොකද්ද මේ දාලා තියෙන්නේ? aluminium powder NaOH. What is this? The aluminum dust test. Aluminum dust test to come up with the NO3 minus ions. මම කිව්වේ nitrate analysis එක තිබුණා අනිවාර්යයෙන්ම aluminum dust test එක use වෙනවා. අනිවාර්යයෙන් use වෙනවා. ඉතින් අමතක කරන්න එපා reaction එකක් ගාලා වඩා කරගන්න පුළුවන් වෙන්න ඕනේ. හරිද? So what they are saying, definitely a reaction will occur and will release some NH3. Some reaction will occur and release some NH3. Aluminum dust test produce the NH3 gas and the Al2 minus, no? Produce the NH3 gas and the Al2 minus, ne? Okay, aluminum dust test එකේ කතාව. When this reaction will give you Al2 minus and the NH3 gas, right? Pardon? Again, reaction, nitrate ionification, right? In basic medium, what will happen? The solution was heated and the gas evolved was transferred quantitatively to react with 20 cubic centimeters of 0.11 HCl. මේ gas එක අරන් මොකද කරලා තියෙන්නේ? එයාව transfer කරලා කොහෙටද? HCl එකක් අස්සට. එයාව transfer කරලා HCl එකක් ඇතුළට. Right? So HCl is there. So its numbers are given as 20 cubic centimeters of 0.11. HCl numbers are given. Okay. Hari, තව කියලා දෙන්න. The HCl remaining after the reaction. HCl remaining. Remaining HCl again කරනවා. Remaining HCl is titrated with what? NaOH. The concentration and the volume are given 0.1 mole NaOH and the volume is 10. That is a data point. Titrations are always coming up as data points. හරිද? දැන් ඔයාලට ප්‍රශ්නයක් දෙන්නම් මෙතනත් නිකන් මෙයා දන්න එකක් වගේ ඉන්නේ. හරි? මෙතනත් ඇත්තට මොකක්ද data point කියලා ප්‍රශ්නයක් වඩේ එන්න පුළුවන්. හැම ඉස්සෙම ළමයි ඒක ප්‍රශ්නයක් ආව titration එක consider කරන data point විදියට. හරි? So actually this is in excess you have added. This value is in excess. Excess is all the. That is why something is remaining after the reaction with NH3 and HCl. Right? Hari. Solve karamu. So you have to bring this Z. Definitely you have to bring this Z towards here. You have to bring this that Z towards here. So that relationship will be provided by the chemical equations. Hari me Z bring gain nonuwa data point එකකින් දැන්ට NaOH දැන්ට. ඒ relationship එක හදලා දෙන්නේ කවුද ඔයාලට? chemical equations ටික. හරි? මෙතන equation එකක් යනවා aluminum dust test එකෙන්. ඊට පස්සේ ammonia HCl reaction එකක් යනවා. ඊට පස්සේ HCl NaOH reaction එකක් යනවා. ඔය reactions තුنين ඔයාලට Z ගේන්න පුළුවන්. ඔයාගේ data point එකට අදාළ chemical එකට NaOH ට. Right? Okay, let's bring those. Let's come up with the equations. Chemical reactions, right? So the first thing is aluminum dust test, right? So aluminium reacting with NO3 minus, right? To produce the AlO2 minus and the NH3. Quickly complete this one. So a 8 electron difference, 3 electron difference, right? So this comes as 3, this comes as 8. I'm calling balance karpu equation එක right? So 5 of OH minus, right? And some 2 of H2O as well. Right? Then what happens? Then this overproduced NH3. This overproduced NH3 is reacted with HCl. Overproduced NH3 is reacted with HCl. So that thing will produce the NH4Cl. Acid base reaction. So then the remaining HCl. This is remaining HCl, right? HCl remaining. Alright, මේ excess දාලා තියෙන්නේ total දාලා තියෙන්නේ remaining HCl තියෙනවානේ. NaOH එක react කරන්න. HCl remaining is reacting with your NaOH to give you NaCl and H2O. Right? So let's bring that data point towards NaOH, right? So Z appears with this, Z appears with NO3 minus. That links to NH3. That is going to be Z mos as well. That is Z mos namai. It was a that Z mos links to here. And here this HCl is the HCl reacted with NH3. HCl reacted with NH3 and HCl reacted with NH3. Here this is the HCl reacted with NH3. Here is the remaining HCl after the reaction of NH3. Right? Okay. Here this is the HCl reacted with NH3. Some HCl amount will react and some will remain. That remaining thing is actually the one which has been reacted with NaOH, right? Okay. So what is the value here? We need to come up with some value here. So Z mos is there. So HCl reacted with NH3 is also Z mos, right? So 1-to-1 ratio with these two guys. So HCl reacted with NH3 is Z mos. Right? 1-to-1 ratio, as you are providing Z mos of NH3, HCl reacted with NH3 is Z mos, 1-to-1 ratio. So then what is the value for the remaining HCl? So remaining HCl appears here, The remaining HCl is the HCl added minus the HCl reacted with NH3. Remaining HCl is what? That is HCl added minus the HCl reacted with NH3. That is remaining ඉතුරු ප්‍රමාණය කියලා කියන්නේ දාපු සම්පූර්ණ ප්‍රමාණයෙන් this is total amount දාපු සම්පූර්ණ ප්‍රමාණයෙන් මෙත් රියැක්ට් කරපු ටික අඩු කරාම right? Okay, this is the total HCl added, right? This is the total HCl added. The remaining again total HCl added value NH එක react කරපු ටික අඩු කරාම තමයි වාට ඉතුරු ටික හම්බ වෙන්නේ. Right? So I'll write the value here. Right? Total added is 0.11. Right? This value is 0.11 mole at 20 cubic centimeters. That is actually 2.2 into 10 to the power minus 3 moles. So that is the total HCl added. So the remaining HCl is actually the total HCl added minus the HCl reacted with the NH3. So that is 2.2 into 10 to the power minus 3 minus Z. Are you guys okay with me? Hurry, okay with that now? Hurry. මේ කියන්නේ total HCl added මේ කියන්නේ HCl reacted with NH3. Okay, more remaining amount again, remaining HCl. So that amount will react with NaOH with 1:1 ratio, right? So the NaOH amount will be the same 1:1 ratio. So NaOH amount එකත් same. So මේ moles ම තමයි වගේ same amount again. හරි. In terms of Z we came to NaOH. Right? Remaining තමයි NaOH එක වැඩ කරනවා. Right? So I'll write the simultaneous equation then here. For moles of NaOH. Right? So this is in terms of Z, right? In terms of Z, the value is 2.2 into 10 to the minus 3 minus Z. It is equal to this CV data, right? This value is actually 1 into 10 to the minus 3, right? 1 into 10 to the minus 3. 0.1 into 10 into 10 to the minus 3, that is 1 into 10 to the minus 3. So your Z will be, right, this goes here, right, 1.2 into 10 to the minus 3. That is the amount of moles of nitrate. Amount of moles of nitrate. Right? And then, finally they are asking the concentrations. පොඩි ප්‍රශ්නයක් උතහල් දියවනේ. Write the balance ionic AD කියලා කියන්නේ කියලා දිනනවා. the reactions එක ලියවන ඔක්කොම. reactions එක ලියලා දිනනවා. Determine the concentrations of this stuff. Let's come up with the concentrations නේ. මෙහෙන් ලියන්න concentrations එක. So now we have found the moles. No? Now it is very easy to come up with the concentrations, right? So first we have found the sulfite තින්නේ මුලින්ම කතා කරමු මොකද්ද sulfate no sulfate concentration no sulfate is actually Y no 7.5 into 10 to the minus 4 moles divided by the volume taken was 25 cubic centimeters. So the value is 10 to the minus 1 is there, right? So 10 to the minus 1 is there, so 0.75 ultimately. Minus 1 is there, yeah. So it is going to be 0.03. So for the sulfite, the value, number of moles value is X, right? X is 1 to the minus 3. That number of moles appear with 25 cubic centimeter solution. So 1 over 25, that is 0.04. Finally, the nitrate amount. Number of moles is this. Divided by the volume. The volume is, yeah, that is Z moles was appeared with 25 cubic centimeters, right? Z moles was appeared with 25 cubic centimeters, right? Okay. So volume is 25. और आप ये का मारा देर ना मैं अपनी मेहनत में इन्वॉल्व कर रहे हैं हमने 25 के लिए नहीं, right? So this will give you 0.048 නේ. හරි තියන්න ඔය විදිහට ඔයාගේ ලිස්ට් එකේ හරි ඉතින් ඔක තමයි ප්‍රොබ්ලම් සොල්විංග් වල කතාව. හරිද? ඉතින් අපි third question එක කරේ, right? ඒවට පුළුවන් question number 2 1 2 3 ටික 1 2 3 4 ඔක්කොම ටික try කරන්න ළමයි. 1 2 3 4 ඔහම 3 කරන්න 4 5 6 7 ඔක්කොම try කරන්න. අපි මේ questions ටික discuss කරමු online class එකේදී. හරි online class එකේ discuss කරමු. ඒ ටික ඔක්කොම try කරන්න. මට පුංචි දෙයක් කියන්න තියෙනවා ළමයි මේ question number 1 එක ගැන. පොඩි දෙයක් දාගෙන question number 1 එක සම්බන්ධයෙන්. අර question number 1 එකේ මේ ammonium salts reactions with NaOH කියන එක appear වෙනවා. ඒක පොඩ්ඩක් අර අපි කතා කරමු නැති නිසා ඔයාලට ඒක අපි ඔක්කොම කතා කරනවා මේ ඕගොල්ලගේ inorganic chemistry වල, right? නමුත් මේකට ඉන්වෝල්ලා තියෙනවා. සාමාන්‍ය වැඩි use වෙන්නේ නැහැ. ඉතින් කලාතුරකින් use වෙන්න පුළුවන්. මම ඒක පොඩ්ඩක් මතක් කරලා ඉන්නම්. Right? How the ammonium salts react with NaOH කියන එක. That will be important to do the question number 1 2017 question. Right? ඒක පොඩ්ඩක් මතක් කරලා ඉන්නම්. Right? ඒක පොඩ්ඩක් උඩට දාගන්න. Right? Ammonium salts with NaOH. මොකද වෙන්නේ? Ammonium salts වල NaOH දැම්මම you produce NH3 gas, right? NH3 gas produce වෙනවා. ඒක පොඩ්ඩක් ඔලුවට ගන්න. ඒක ඕන වෙයි. ඔයාලට first question එක try handle කරන්න. ඊට පස්සේ ඒව ඔක්කොම තනියම කරන්න පුළුවන්. හරි? ඊට පස්සේ දේවල් අපි කතා කරපු දේවල් තියෙන්නේ. හරි? මම පොඩ්ඩක් උදාහරණ කිව්වොත් if you are thinking of NH4Cl with NaOH, what will happen? You can consider this one as a summation of NH3 plus HCl. This is how to derive the equation, right? The ammonium salts reaction with NaOH. So what happens is this NH3 releases easily. That NH3 releases easily, and the HCl will react with the NaOH. HCl will react with the NaOH. That will give you HCl NaOH reaction will give you, right, NaCl and H2O, right? That is how we are supposed to come up with the ammonium salt reactions with strong bases like this. So example like one name ammonium sulfate with NaOH. With any strong base this thing will appear. See? So ammonium sulfate can be seen like ammonia plus H2SO4. ළමයි බලන් තියෙන්නේ අර ammoniaයි corresponding acid එකයි. SO4 2 acid එක. Cl acid එක. Right? එතකොට reaction කොහොමද ලියන්නේ? First the ammonia thing will release. So you have 2 of ammonia there, right? 2 of ammonia there. Then these two things. The reaction of H2SO4 with NaOH will give you the salt and water. Alright? ඊයෝම තමයි ammonium salt reactions ලියන්නේ. ඕනේ අකල් nitrate ලිව්වොත් එහෙමයි. කවුරු ඕනේ ammonium salt reaction එක ලියන්න ඕමයි. Consider your ammonium salt as a summation of ammonia plus corresponding acid. NH3 plus NO3 corresponding acid of your anion, right? So first the ammonia will release and HNO3 with the NaOH acid base reaction will give you the salt plus water. Alright? ඉතින් ඔහොම ඕන ඇමෝනියම් රියැක්ෂන් එක ලියා ගන්න පුළුවන්. ඉතින් ඕක ඔයාලට අවශ්‍ය වෙයි. question number 1 එක කරන්න. පොඩ්ඩක් මේ note එක දාගන්න. Ammonium salts are acidic so that will react with strong bases to give you ammonia. Right? හරි. ඉතින් ඕකත් එක ළමයි ඔක්කොම questions try කරන්න. questions අපිට තියෙනවනේ 8ක් නේ. 8ක් තියෙනවා. question 8ම try කරන්න. හරි. ඊට questions ටික අපි කතා කරමු අපේ online class එකේදී Wednesday night. right? ඔක්කොම try කරන් ඉන්න හොඳේ. මම ඒ වෙලාවේ ඔයගොල්ලෝ ලියන්න වැඩි කතා කරන් මේ ඒ වෙලාවේ ලියන්න වෙලාව දෙන්නේ නැහැ. I am just discussing right at the online class right. දැන් ඔයගොල්ලෝ හොඳට try කරලා ඔක්කොම questions හදාගෙන ඉන්න. හරිනේ. Ammonium salt reactions. ඔයසේ ammonium salt එකක් consider කරන්න ammonia plus corresponding acid is එතකොට ලීසි ඒවා solve කරන්න reactions ලියන්න. ammonia release වෙනවා acid එකයි base එක react කරනවා. give you the salt and H2O. balancing is also easy. හරිනේ. හරි මේ අපි වෙනම කතා කරනවා P block ගැන කතා කරද්දී වෙනම P block වලට සෙමින එකක් තියෙන දවසක් කරන ඒ දාට මේව කතා කරමු මේ කැලේ වලට ඕන වෙනවා මේක ඊට ඉතුරු රියැක්ෂන්ස් ඔක්කොම අපි කතා කරලා තියෙන්නේ නෝට් එකකින් වල ගන්න පුළුවන් හරිනේ ළමයි එහෙනම් අපි අද නවතිමු right okay then goodbye then see you next week right